Hi, my name is Vanessa, and today I will be going through the code that myself and Connor created, and I will be explaining the different functionalities it has. So the code has 5 main classes: the order class, the customer class, the restaurant class, the delivery class, and the collection class. So I will briefly show you this on a UML diagram and the different relationship they have. There's the association relationship between the order and the customer. There's the composition relationship between the restaurant and the order, and there's the inheritance relationship between the delivery and the collection. Here we will start with the header file. The header file is used to share information among various files. So in the public section, we have the set and get functions like set food, set order, get food, get order. The set food sets the value of the private member variable food, like you can see in here. And then the get food function is called on the object, and the value of the food variable is returned. We also have the customer get distance kilo here. We can see how the order is associated with the customer class. Then the void set distance. This is using the customer reference to associate customer and order. We also have the virtual function, which is very important for this project. A virtual function is a member function which is declared within a base class and is overridden by a derived class, also known as polymorphism. Which means having many forms. So the word virtual here is used in this function for it to work, as you can see. We also use the friend function. So friend function can access the private members of a class as though it were of that class. And also we used overloaded or stream operator implemented as friend functions, which you will see later. So then we also have the private data members. So here they're the food and the order number, and also here we can also see an association relationship between the customer and the order. So in the order CPP file, this is where all the functions are. We can see the order constructors like food, and the order number. Food is set to spice bag and order is to 1. We have the set functions. So here the set food takes a parameter f and assigns it to the food attributes f. This happens with set order number. But then we also have to get. So the get function here returns the value of the private order number attributes. We do this for the get distance, kilo, and the send distance. So this function, the display order details, this function prints out the details for each order of the restaurant, like the food, the order number, and the distance from the restaurant. Here we also included a destructor. This is how a destructor is written. We also have the overloaded assignment operators. So I will show you. So there's different tests. The overloaded operator. So this is the overloaded inequality operator implemented as a non-member friend function. Then we have the overloaded inequality operator implemented as a non-member function. And we also have the overloaded OStream. So I will show you this when it loads, when it compiles. So you can see that clearly here, how the spiceback got the order spiceback and the order number 1. This is also another overloading operator test that you will see in the main here. Testing for equality and inequality. Then we come to the customer. So for the customer, we also have a header file. So this header file, like the order file, so this header file contains overloaded constructors, contains the set methods, which have the set name and the set distance. And we also have to use the get function with the get name and the get distance. But here we're also using a static function, which is used to return the value of the static variable, which is the get max distance. You will see the function for this in the CPP. And also again a display function. Here the private members are the distance, the max distance, and the name. So in the customer CPP, you can see the constant flow function. So here it defines and initializes the static constant variable outside the class. So the max distance is set to 10 kilometers. Here you can also see the customer constructor, which is the name. And here we set the name. So again, the set name takes the parameter n and it assigns to the name attributes. So name equals to n. So then we get the set distance. So here, if the distance entered is bigger than the max distance 10, there is an error in the code and the customer is too far from the restaurant. So that means it needs to enter a distance less than 10. That's what the else is for. So here again, we use get to return the value of the private member attributes. And again, we have a display function to display the customer details. And again, there's also the structure, which is very important in our code. So we come to the restaurant header file. So here we have, again, the sets and the gets. But here we have pointers that are included. So we include add order pointer, which this is the sign for a pointer. We also have the remove order, add order, and find order, which will be explained in the CPP file. Here we can see the overloaded equality operator and the overloaded inequality operator. We also use the STL sort algorithm, which is quite important. And our private members are the restaurant name, the restaurant orders for the pointers, the max number of orders, and the bool function. So here in the restaurant CPP, we have a few things. So we have a function that removes an order from the restaurant. Here we can see this when we run our program. So here we can see after removing the restaurant order. I will talk to this later on. Here we have the restaurant constructors and what's next is then how we initialize the constant variables using a construction initializer list. We do this again, and again we use the set function and get function for the restaurant name. So the add order function is quite important. So this adds an order to the restaurant. So if the orders are less than the maximum of 15 orders, your order will be added to the restaurant, but if it's using else, if it's more, your order won't be added. So again, we have pointer field. This is another important topic. So in lecture 5, we learn about pointers and they're used in this class. So a pointer is a variable that holds a memory address as its value. So a pointer usually contains an asterisk between the data type and the variable. We also have a bool function. So this is a type of function that can hold only two variables, which is true or false. So again, we have the display restaurant details, which prints the restaurant details like the name, the max number of orders, which you will see later in the compile of the code. So again, we have the polymeric call to virtual functions. So this code should polymorphically call the appropriate display order details over in their virtual function. And then in the end, we have the STL and overloading operator. So we have the code to find an order, which you will see in the main. And then you have the print order by order detail. So this function calls the STL sort algorithm. The order objects contained in a restaurant according to the criterion specified by overloading the less than operator in the order class. Then we come to the delivery and the collection classes, which are quite simple and not that long. So here we can see how this code implements the inheritance association between the delivery and the order class. Here we can see the overridden overridden function of the set order food, and in the CPP file we can see how these are created. So the add order function is created here, which adds an order that it is to be delivered, and then here it's only the delivery orders that can be delivered. So this function here prints out the details for the delivery details that you will be seeing in the main. For the collection, it's similar to the delivery. So here again is the interference association relationship. Also, there's an overridden function here with the virtual void display order details. So this overrides the display order details function in its parent order class. So again, collection is quite similar to the delivery. So here we have overridden functions, and we also have the display order function. So this line calls the parent class display order details function. So now I'll be going through the main, which is the most important. This is the main calls all the functions. So we have an order. So here we created an order object O1. Here we set the food and the order number. So there is 3 order objects with 3 different food types. So we also did a lab set, we also did a testing for the overloading operators, which you can see here. You can see that here, and you can also see the 3 orders. This first test tells us that order 1 and order 2 are not the same. The second test tells us that order 1 is further on in the alphabet. We also created a 3 customer objects, and we showed the max distance length for a customer. We used the association relationship here for the order object and the customer object. So here O2, the second order from the order class, is associated with D2, the second distance from the customer class. See, also a restaurant object was created, and here we added orders. So this is the function add order, which adds O1 from the order class to O1, the restaurant class. And here the print ordered by order title. So this orders the order object that are part of the OR1 restaurant object. So here we come to the delivery class and the collection class. So the delivery class, so this creates a delivery object dev1. So dev1 will have access to the public functions in the parent class order and the child class delivery. Here we have the set function for it and the display order details. The same happens for the collection class. And here we set the restaurant name and the max orders. So here we have, this is the function add order, which adds dev1 from the child delivery class to OR2, the order delivery class. You can see this all when the code is compiled. So this is the add order. This displays the restaurant details, and this is the find order function. And at the end, we have the remove order, which you can all see now. So this is the overloading operators. Here we have the sorted vectors with the overloading operators. Here we have the delivery details, the collection details that we've seen at the end of the main. These are the restaurant details, the name, the number of orders, and then the orders in the restaurant. There are 3 orders in the restaurant. There's the food, the order number, and the distance from the restaurant. And here the sorted vectors are printed out. And the find order function is also used here. You can see the food order for collection 3 and 1 can be found in the restaurant. And also we have the removing of the restaurant order, which is here. So here we can see how the delivery details were removed, and we only have the 3 details of the class of the code.